Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Kafir Sukar bin Ahmad Arkaf. For today's lab, I'll be discussing about the fluid dynamics control volume experiment. So, without further ado, let's move on. The overview of the experiment. The name of the experiment is called the impact of a jet experiment. So, in this experiment, we will be investigating about firstly control volume. So what is control volume? One might ask. Control volume is a finite region of the fluid that we are interested in. Now the control volume is selected to study the effects of flow, in this case which is force, which is by considering the mass flow rate. These forces can be determined as in solid mechanics by the use of Newton's second law, which is the linear momentum equation. As you can see here in the blue boxes, this is Newton's second law. At the bottom is the simplified, it's the derived version, which is summation of F equals to summation of rate of momentum, summation of m dot v in minus summation of m dot v out. So in this experiment, we will consider the method of momentum of force. In this experiment, we will consider the method of momentum of force by measuring the forces produced by a jet of water impinging on solid flat and curved surfaces, which deflect the jet at different angles. So moving on to the theory part, here are 1, 2, 3, 4 equations that we will consider in order to complete our experiment. So the first equation is V equals to Q over A, where the V is the velocity of water leaving the nozzle, A is the cross-sectional area, and Q is the flow rate. When we apply energy equation between the nozzle exit point and the surface of the deflector, shows the deflector shows that the magnitude of the flow velocity does not change as the water flows around the deflector. Only the direction of the flow changes. Now, when we apply momentum equation to a control volume that is encompassing the detected flow, this results in the second equation, which is Fy equals to rho qv cos theta plus 1, where the Fy is the force by deflector on fluid, the rho is the fluid density, Q, as mentioned before, is the flow rate, and the theta is the flow deflection angle. Equation 3, W equals to rho qv cos theta plus 1. Now from equilibrium of forces in a vertical direction Fy, this is balanced by the applied weight on the weight pen. Later we will see the setup and the weight pen will be shown there. This is balanced by the weight pen W, where W is equals to mass times gravity. Therefore W is equal to rho qv cos theta plus 1, since Fy is equals to W. Since Q equals to Va, the equation can also be derived as follows, which is equation 4, W equals to rho Av squared cos theta plus 1. Now the aim of the experiment is to investigate the reaction forces produced by the change in momentum of a fluid flow when a jet of water strikes a flat or a curved surface, and to compare the results from the experiment with the computed forces by applying the momentum equation. Later on, we will compare the motive is to compare the experimental results with the computed results. So this is the setup. The setup is as shown, which is F116 impact of jet apparatus. So at the topmost here is the weight pen. We have a lever gauge, a spring, a nut screw, target plate, a nozzle, adjustable feet, and inlet pipe. The equipments are as follows: F110 hydraulics bench, F116 impacts of a jet apparatus with 3 flow deflectors with deflection angles of 90, 120, 100 and 180 degrees. And last but not least, we need a stopwatch for timing the flow measurement. Now how this setup works is that the jet apparatus, the clear acrylic cylinder, water will enter vertically from the top of the cylinder through a nozzle, striking a target which is mounted on a stem, and it leaves through the bottom outlet holes at the base, and there is an air vent at the top of the cylinder that helps to maintain the atmospheric pressure inside the cylinder. A weight pen at the top of the apparatus is mounted at the top. This is to allow the force of the striking water to be counterbalanced by the applied masses. So here are the procedures in order to conduct the experiment. They are quite long, so I will simplify the procedures. So first and foremost, we will remove the top plate. Then we replace the cylinder, connect the inlet tube, replace the top plate, which is on the transparent cylinder, and then we level the cylinder by adjusting the feet. Replace the 3 nuts, ensure that the vertical shaft is free to move. Next, we adjust the height of the level gauge. Place a mass of 50 grams on the weight pen. So our mass that we use is 50 grams. Open the bench valve slowly. Next, we measure the flow rate. Moving on, we should repeat this procedure by adding 50 grams incrementally until maximum of 500 grams. Last but not least, repeat the entire test for each of the other 2 flow reflectors. So here are the calculations that we are interested in. First and foremost, the diameter of the nozzle and the cross-sectional area of the nozzle should be as mentioned in the experiment, which is 0.008 meters for the diameter and area of 5.0265 times 10 negative 5 meters squared. Each set of measurements, we need to calculate the applied weight, flow rate, velocity squared, the force in the y direction, the theoretical and experimental slope of the relationship between W and V squared. Last but not least, the experimental value of S from a graph W plotted against V squared. So for the theoretical slope, the equation is as follows. Equation number 5, S equals to rho A cos theta plus 1. From the calculation, we get the results and fill the table with the results. Here are the things that we need to consider. There are 10 tests. Applied weight, this is the increment until maximum of 500 grams. Next is the flow rate that that we need to consider, the velocity squared, and the force. And the theoretical slope can be calculated from the equation 5. Experimental slope is from the experiment. So for the discussion part, human error may be present in the experiment, and then we need to compare between the experiment and calculated results, and then we need to verify whether this method is viable or not, and whether it proves that Newton's second law or not. So from the calculations and results that we obtained, it should be that Newton's second law in this experiment is proven. And fluid flows can lead to a reaction force in the following ways: linear momentum, flow variation in direction and or magnitude, fluid pressure forces, fluid friction forces, and fluid weight. But in this experiment, we are considering linear momentum, flow variation in direction and or magnitude. The end.